Hello, Woodrow Wilson friends and family. This is Miss Fields here, and you are joining me for our 12th episode of Math Toolbox. So tonight we're going to be focusing on part 1 of 2 of the culminating part of our unit where we are learning to divide decimals by whole numbers. In the next video, you guys are going to be learning how to divide decimals by decimals. So we're going to start with part 1, dividing decimals by whole numbers, and see what processes we need to use in order to do that. Now this is kind of the culminating end skill of learning how to add, subtract, and multiply decimals and putting it basically all into one. So this is the grand finale for decimals and operations with decimals. So typically, whenever you encounter a decimal division problem, it is going to be inside of a word problem. So let's use this one as an example. On Saturday, 12 friends go to a Bees baseball game. Altogether, they pay $83.40 for tickets. They share the cost equally. How much does each person pay? So I don't know about you, but seeing all of these words kind of overwhelm me. So in my brain, I'm thinking, how can I break this down visually and also mentally so that this word problem makes sense? Now, if you're thinking what I'm thinking, you're thinking Foursquare. Let's divide all of this up into a Foursquare so that we can mentally organize what's going on in the problem. So we start with our top left box, which is UKT, and we're going to start with this U, which stands for units. So units are typically found around numbers because they describe what the number means, and they give us a lot of information about what operation we're going to be using to solve the problem. So in this problem, I see that we have 12 friends, that's one unit, and we also have $83.40, which is another unit. So in the part called U, units, we are going to put numbers and friends. So seeing that we don't have matching units tells me two things. We're not going to add and we're not going to subtract, because you can't add or subtract things that are not the same. You can't add dollars with friends. You can't add friends with dollars. Moving on to narrow it down, because we know we could either multiply or divide, we're going to go with keywords. Now immediately, this phrase, share the cost equally, tells me a few things. When I'm sharing, I'm divvying up things. And when I'm sharing it equally, I know for a fact that I am dividing. So anytime you see a phrase like share equally, divides equally, separates equally, you know that you are dividing. However, for the sake of going through the UKT process, we need to look back in the word problem and see, do we know the total or do we need to find the total? Now we know that we have $83.40 in total. The friends aren't spending any more than that, so we know that we have the total. We're trying to figure out how we are going to divide that up among the friends equally. From there, we're going to set up our division problem. Under the division bar, we've got our dividend, which is $83.40. And off to the side, our divisor, we know that we're going to be dividing this amount equally between the 12 friends. Now, whenever we're dividing a decimal by a whole number, if there's a decimal under the division bar, in our class we say there's a decimal in the house, raise the roof. And what we mean by that is we're going to add that decimal into the specific place value in which it should be. So right after the 3, right after the ones place in $83.40, we're going to raise the roof. We're going to put our decimal there as a placeholder, and then we're going to begin the division process. So in our class, we use a chant which goes divide, multiply, subtract, bring down. So whenever we're looking at our dividend, we go digit by digit using the standard algorithm, and we make that chant. So if we're looking at our digit 8, can we take away any groups of 12 from 8? We know we can't. We can't divide. We put a 0 as the placeholder. Underlining these next two digits, and they become 83, we know that we are going to see how many groups of 12 we can take away from 83. Now, I know I don't have our guess and check visible for us to see, but in the bottom left corner of our Foursquare, which we'll see later, you would try as many different multiplication problems of 12 as possible to get as close to 83 as you possibly can. Now I'm going to guess 12 times 6, and another thing that you could use if you don't want to guess and check with a divisor of 12 is you could use your multiplication chart and see how close this divisor gets to 83. So I'm going to try 6. So we divided up 83 into 6 groups. Now we're going to multiply. I know that 12 times 6 is 72. That's as close to 83 as I can possibly get. Our next step is subtract. 3 minus 2 is 1. 8 minus 7 is 1. We get 11 as our difference. Last step is bring down. We need to bring the digit down in order to make a new partial piece of our dividend. Our next step is we are going to see how many groups of 12 we can take away from 114. Now again, if you have a divisor that is inside of our multiplication chart, which we talked about how to use in previous videos, you can move along your multiplication chart until you see how many groups of 12 you can possibly get as close to 114 as possible. Unfortunately, it's not going to be perfectly equal, so you're going to have to get as close as possible as you can get without going over. So we can get as close as possible to 114 as 9 groups of 12. So we divided 9 groups of 12 into 114. Then we multiplied 12 times 9, which is 108. Now we need to subtract. We know we can't subtract 8 from 4, so we need to regroup this 10 and pull it over here into 10 ones. 10 ones plus 4 ones is 14. 14 minus 8 is 6. 0 minus 0 is 0. 1 minus 1 is 0. Our last step is bring down. Last step, look at 60. We're going to see how many groups of 12 we can take away from 60. In my mind, because I'm a proficient multiplier, I know 12 can go perfectly even into 60. If you don't know that, use your multiplication chart, use your resources, and investigate. See if you can get equal groups of 12 from 60. So I know that 5 groups of 12, can go into 60 equally. Our next step in the problem is to multiply, just to double check that we have the correct quotient. 12 times 5 is 60. Next step is subtract, zeroed out. Once we're zeroed out, we know that we have completed the division process in its entirety, and now we are going to look to our quotient. So I'm seeing 6 and 95/100ths. However, this doesn't have any meaning unless we look back to what the problem's asking us. So you can find what the problem is asking you by looking at the last sentence of the word problem. It says, how much does each person pay? Looking back at my quotient, I see 6 and 95/100ths. However, that doesn't make any sense. There's no unit attached to it. I need to add that dollar sign back in, and I'm going to state my solution. Each friend will pay $6.95 for their ticket to go to the Bees game. Now really quickly, one thing that I want to point out to you guys is our check and guess box over here. I didn't feature it while we were solving the division process. However, as I'm going through this division process, I would be using this check and guess box repeatedly. It's important to keep track of your work in the check and guess box because as you're going through the division process, even if you don't get a check and guess that actually can be used right away, you can always go back and refer to these whenever you're trying to see how many groups of a number you can take away from the dividend. Thank you so much for joining me tonight. Dividing decimals by whole numbers is super simple with lots and lots of practice. However, it is a culmination of all of the skills that we've used so far. So if you're still stuck on concepts of multiplication, or if you're still stuck on concepts of subtraction, or if you're still stuck on how to use your multiplication chart, look back at the previous videos that I've created and sharpen up those skills. I can't wait to see you guys tomorrow. Have a good night.